This is Unit 5, Day 9. And this is the discriminant, which is helping you determine the nature of the roots. Okay, so discriminant. It says remember the quadratic formula, and that's stated right here. And then it talks about the quantity underneath the square root. So the b squared minus 4ac is the discriminant. The purpose of the discriminant, if you read under example 49, it will tell you whether the quadratic, whether they are rational, irrational, or imaginary. It also lets you know how many there are. Okay? So to determine the discriminant for each of these, you're going to just do the formula b squared minus 4ac. Okay? So the first one, I'm going to do all the work for you here. But this has where a is 1, b is 4, and c is 13. So to find the discriminant, it's going to be b squared minus 4 times a times c. So the discriminant ends up being 16 minus 52, which is going to be negative 36. Okay? Anytime there is a negative number, you know that it's going to be imaginary. Okay? Because it should make sense. Because the discriminant is the part underneath the radical. If you have a negative underneath the radical, there's going to be 2 imaginary roots. Okay? Alright. If it's imaginary, it's not crossing over the x-axis. Okay? So now actually this sketch, I think, let me make it a little bit more accurate. If you put it in your calc, it's going to be something like this, I believe. Okay? The actual roots. You're going to use the quadratic formula to find the roots. Okay? So that would be the opposite of b, so it's negative 4, plus or minus, and it's going to be the square root of negative 36. Because don't forget, we just figured out the discriminant right there, and then that's all over 2 times a, which is 2. Okay, so that ends up being negative 4 plus or minus 6i over 2, and when I reduce that, I get negative 2 plus or minus 3i. So those are my 2 roots right there. Okay? That's all review for you guys. Alright, so that first one, there was 2 imaginary. Case 2, okay, the discriminant. So you're going to do negative 8 in parentheses squared minus 4 times my a times my c, and you get that your discriminant is 0. Okay? Anytime the discriminant is 0, if you were to graph this, there's 1 rational root. Why is there 1? If you graph this, it is tangent at 4. So you end up with it looking like this. Okay, it's tangent to the x-axis. So that's why there's only 1 rational. So every time it's 0, there's 1 rational. To find the root, the opposite of b, so it'd be positive 8, plus or minus the square root of 0, which is 0, all over 2 times a, which is 2. Okay? So when you multiply that, you're going to get, I'm sorry, when it's going to be 8 plus 0, it's 8. 8 over 2 is 2. I'm sorry, let me start over. So 8 plus 0 is 8. 8 divided by 2 is 4. Okay? But also, if you did 8 minus 0, that's also 8. So you get 2 4s. Okay, so it's 8 minus 0 over 2, or 8 plus 0 over 2. Both result in 1 single 4. Okay? Case 3. Discriminant. Your b squared is negative 7 minus 4 times your a times your c, and you get that the discriminant is 81. Okay? Notice that that is a perfect square. Anytime it's a perfect square, you have 2 rational roots. Okay? That means the answer comes out nice when you sketch it. So I think it ends up being negative 1 and positive 4. So this would cross over right there. Now, guys, I'm just freehanding the sketch. The turning point might not be accurate, but I'm just letting you know that the roots are actually nice there, though. Okay. So this one's going to be the opposite of b, so it's 7 plus or minus. The square root of 81 is 9 all over 4. So when I do 7 plus 9, I get 16. 16 over 4 is 4. That's why it made sense that that one's 4. If I go 7 minus 9, it's negative 2. Negative 2 divided by 4 is negative, oops, that's supposed to be a half, guys. That's negative a half over there. Okay? So we've had 3 cases so far. I'll review them in a minute. Case 4, your discriminant, your b squared, so negative 10 squared, minus 4 times your a times your c, and I end up with a discriminant of 48. Okay? It is an irrational number. So if 48 is sitting underneath a radical, the square root of 48 would be irrational. So that means it crosses not in a nice area. So like it would fall between 2 numbers. Now guys, that's an estimate. I don't know if it's really falling between 1 and 2 or 3 and 4, but they're not nice. That's all I'm trying to show you right there. Okay, so the opposite of b would be 10 plus or minus. The square root of 48 is going to be radical 16 times 3, which would be 4 radical 3 over 2. That simplifies to 5 plus or minus 2 radical 3. Okay? So there are 4 cases. Negative ends up being 2 imaginary. 0 ends up being 1 rational. Okay? Because it's tangent. Case C, it's a perfect square. If it's a perfect square, there's 2 rational. Case D, or part D, case 4, it's not a perfect square. And if it's not a perfect square, then it ends up being 2 irrational. These are the only 4 cases it can be. So on the next page, it talks about everything right here. Okay? If a number is less than 0, that really means negative. If it's negative, there's 2 imaginary roots. They say unequal because it means they're not the same. That's all that means. Okay? Graphically, there's no x-intercepts. It's above it. Case 2, when it's exactly equal to 0, that's when there's 1 real. Okay? That's when it is tangent. Okay? That was case 2. Case 3 is it's greater than 0, but it is a perfect square. There's 2 rational. Okay? It can also be greater than 0, but it's not a perfect square, so there's 2 irrational. Okay? Those are the 4 cases. They're not that hard, but you do have to memorize them. Okay? So moving on to example 50 here. It says, by using only the discriminant, determine the number and the nature. So the number means how many. Okay, so that means like how many. So is there 1 or is there 2? Okay, there's always 2, guys, unless it's equal to 0. Then there's only 1. And then the discriminant, you got to remember, is b squared minus 4ac. Okay, that is not given to you. You do have to know that part of it. All right, so ready? ABC. So ready? The first one, I'll do the work. So it is b squared. So I'm going to get 7 squared minus 4 times my a times my c. And I calculate that the discriminant is 81. Okay? In your head, you need to say that that is a perfect square. So there's 2 rational. Okay? Part B. Calculate b squared minus 4ac. You're going to get your discriminant is negative 36. The second you see that negative, you know there's 2 imaginary. Anytime it's negative, it's imaginary. Part C. Okay, if you need a refresher again, A is 4, B is 4, C is 1. B squared minus 4 times A times my C, I'm going to get that my discriminant is 0. It's 16 minus 16. Anytime it's a 0, there's 1 rational. Okay, that's the tangent. That means it's sitting right on the x-axis. D, b squared minus 4ac. My discriminant is going to be negative 24. It is negative again, so there's 2 imaginary. Okay, the discriminant for part E is 128. Okay, it is not a perfect square, so there are 2 irrational unequal roots. Okay, and the last one here, part F, your discriminant ends up being 25. In your head, you say 25 is a perfect square, so there's 2 rational. See how easy that is? There's always only 4 cases. Example 51. Which of the following quadratic functions, one graph, would not cross the x-axis? In your head, if it's not crossing, it's imaginary. If it's imaginary, it's going to have a negative discriminant. Okay? So what you're going to do is you go through all of these choices and you're going to calculate the discriminant. On choice 3, you will get that the discriminant is negative 64. And because it is a negative, you know that it is imaginary, therefore it does not cross the x-axis. Okay, choices 1, 2, 3, and 4, your discriminants come out to be non-negative numbers. Last example here, 52. Which of the following parabolas has 2 rational? The second it says rational in your head, you need to think it has to be a perfect square. Okay? So you're going to calculate each of the discriminants, and you want to know which one's going to be a perfect square. And when you go to choice 2, your discriminant ends up being 64. And because 64 is a perfect square, you know there's 2 unequal rational x-intercepts.